Welcome to qnawire.
Here in this problem, we have to find that how much energy is required to convert, or you could say the change 40 gram of ice. We can write that mass of ice is given as 40 gram. If you convert it into kgs, we'll get 0.04 kg. So we have to convert this gram of ice, which is at 10 degrees Celsius. The initial temperature is given as minus 10 degrees Celsius. And we have to convert it to steam at 110 degrees Celsius. Now the procedure will follow is that first of all we'll convert minus 10 degrees Celsius, it's ice, to 0 degrees Celsius ice. Then 0 degrees Celsius ice will be converted to 0 degrees Celsius water. And then we'll go to 100 degrees Celsius water. And then we'll go to 100 degrees Celsius vapor. And then finally 110 degrees Celsius steam. So this is the procedure that we're going to follow. So to convert, let this be as first process, let this second process, third process, fourth process, and fifth process. So for the first process, we'll need sensible heat. Here we'll need sensible heat, and here we'll need latent heat, and latent heat of fusion. And here again sensible heat. Here again latent heat, but here it will be latent heat of vaporization. And here again sensible heat. So the latent heat of fusion for ice, it is equals to 3.33 times 10 to the power 5 joule per kg. And the latent heat of vaporization is LV is equals to 2.26 into 10 to the power 6 joule per kg. So heat will be equals to Q. Its mass. First of all, we'll write the heat for the first process. That means the mass times the, dot should not be there. So times the specific heat of ice, that is Ci, into delta T. That means the change in temperature. So change in temperature here is 10 degrees Celsius. So we can directly write 10 degree plus the latent heat times the mass, means M times LF, plus now for the third process we'll need mass of water times the specific heat of water times the change in temperature. So here change in temperature is 100 degrees Celsius, plus mass times the latent heat of vapor, plus mass times the specific heat of steam, that is Cs, times the change in temperature. So here change in temperature is 10 degrees Celsius. So now we can plug all the values. Mass we know it's 0.04 kg times the specific heat of ice. We know it's 2090 joule per kg degree Celsius times the change in temperature we already know, that is 10, plus mass is 0.04 kg times the latent heat of fusion is 3.33 into 10 to the power 5 joule per kg times the change in temperature is no need to write because it's directly M dot LF, so no need to write, plus M here is 0.04 kg times CW, that means the specific heat of water is 4186 joule per kg degree Celsius, and the change in temperature is 100 degrees Celsius. Plus next we will have to write this, that means mass is 0.04 kg and the latent heat of vapor is 2.26 times 10 to the power 6 joule per kg Kelvin. Sorry, joule per kg only, not Kelvin. Plus mass is 0.04. Cs is specific heat of steam, that is 2010 joule per kg degree Celsius times the change in temperature, that is 10. So we're going to add all these terms and finally we'll get it will be equals to 1.22 into 10 to the power 5 joule. This is equal to Q. So finally we can conclude that the amount of heat needed will be equals to 1.22 times 10 to the power 5 joule. So this is the final answer.